Okay, do you remember? No, you don't remember. X is greater than 2 on a number line. How did we graph that?
2, 3, and
I'm moving around.
1.
So it doesn't go black.
And then it goes that way.
Okay, we had a 2.
3.
1.
Open circle. Why open circle?
Yeah.
Because
It's not equal to.
it's not equal to it, but it's greater than it.
Right. Because if 2 was included, it would be saying that 2 is greater than 2. Well, 2 is not greater than 2. So that means 2 doesn't count, but everything to the right of it does. If I put greater than or equal to, then you color it in. Well, that's the same concept of graphing inequalities on a coordinate plane. Now, you can't do an open circle, but let's talk about y is greater than x plus 3. Can anyone give me an ordered pair that would work? There's an infinite amount of choices, guys.
5.
5? That's not an ordered pair.
2, 3.
That 2 plus 3, 3 is not greater. Doesn't work.
5 and 10.
5, 10 works. How about another one, Joel? Negative 3 what?
0.
Negative 3, 0. Doesn't work. 0 is not greater than 0. Another one.
6, 11.
6, 11. 11 greater than 6 plus 3? Yeah. There's an infinite amount of ordered pairs that work. Your goal is to find all of them and plot them on a coordinate plane. Okay?
What?
I'll show you how. It's really not that hard. You got to know how to do one line so that on Monday we can do systems. Okay, here's a coordinate plane. There's the x and y axis. I'm going to pretend that it's y equals x plus 3. That's what you're going to graph. Okay, so let's go up 3, and then up 1 over 1, up 1 over 1, right? This. Now, all the points on this line, make them equal. But what happens is, since it's greater than, and not greater than or equal to, none of the points on this line work, because they're all equal. Instead of a open circle, we dash the line. That means this line is your boundary. Okay, that's the boundary. Everything above this is going to work. Everything below it is not going to work. And this is why I asked you the above and below things. If it's greater than, you are shading everything above it. If it's less than, you are shading everything below it. Now my suggestion is, in case you screw that shading up, pick any point and see if it works. If it works, that's where you're shading. If it doesn't work, that's where you leave it unshaded. Unless it goes through 0, 0, I choose 0, 0. Because to me, that's the easiest one to check. If I put in a 0 and a 0, is 0 greater than 3? No. Notice I don't have that side shaded. Pick a test point. Now, we picked 6, 11. 1, 2, 3, 4, 5, 6, 11. That's right there. It works because it's in the shaded area. We picked 5, 10. 5, 10 is right there. Every single point here makes a true statement. If this was greater than or equal to, how would I change it? That means all the ones on the line, huh?
Make it a solid line.
Make it a solid line. Thank you. Okay. because all the ones on the solid line now work. So, if it's greater than, it's a dashed line and everything above it. Make sense? Or you can just do a test point. You don't have to know this. Just test the point and then you know which side to shade. If it's greater than or equal to, let's go the other way, where's the greater than side? Over here. Greater than or equal to is a solid line and everything above it. I'm probably not in the camera, am I?
No.
Yeah, well, I should have done it over here. All right. If it's less than, it's a dashed line and everything under it. If it's greater than, it's a dashed line and everything above it. If it's greater than or equal to, the only difference is you make it a solid line. If it's less than or equal to, keep the solid line and everything under it. But the easiest way is to pick a test point, see if it works, and then you know which side to shade. If you graphed it right. If you didn't graph it right, that test point's not going to do you any good. You might think you got it right, and it's not going to work. So let's do a couple, okay? Y is less than or equal to negative x over 2 minus 5. Okay, what is the y-intercept?
-5.
Negative 5. So we're going to go down 5. Now, how do I climb? Down 1, right 2. Down 1, right 2. Down 1, right 2. And so, up 1, left 2.
At the bottom.
Okay, now, solid line or dashed line?
Solid.
Solid. Above or below?
Bottom.
Now let's say you're not sure where to shade it. Pick a point. See, this is why I picked 0, 0. Because 0, 0 gets rid of fractions. If it's 0, 0, is 0 less than or equal to negative 5? No. And that's why I don't have that side shaded. Make sense? What we're going to do on Monday is have two lines. Maybe this one goes this way, and then we shade this one, and where they overlap is the answer to your story problem. Because your story problem answers have an infinite amount of answers sometimes. And I'll show you what I mean by a story problem having an infinite amount of answers.
Okay.
Over there is a story problem. If you're home, it's on your notes. It's on the back. Okay? I'll read it to you. Ada has, at most, 285 beads. Okay? She's going to make jewelry. She's going to make bracelets and necklaces. It takes X equals necklaces and Y equals bracelets. So she can use a combination of beads for necklaces and a combination of beads for bracelets, and she's got at most 285 beads. What's at most? What sign is at most? Less than or equal to, right? She doesn't have more than 285. She only has 285. Is that over there? No. All right, so necklaces take 40 beads. Bracelets take 15. We're going to graph this inequality. Now, when you're graphing an inequality with all these big numbers, I don't know if you remember, but all you have to do is find the x and y intercept. You know what I'm saying? And just connect the dots. That's when, remember, you make x 0 and you find y. You make y 0 and you find x. So let's say, well, let's just do it. Okay, if I make x 0, it's 285 divided by 40, and that came out to approximately 7 point something, okay? So let's just put, about 7. You're not gonna be exact, because you'll have some beads left over. Okay, if I cover up the, no. Do I have it backwards? No, that's right. Okay, if I make the other variable 0, it's 285 divided by 40. I already have it worked out. It's 19. Came out exact. So, remember how to graph this. All right, here's our necklaces, and here's our bracelets. 0, 19. Let's just say that's 19 right there. And 7, 0. Let's pretend it's right there. Solid line or dashed?
Solid.
Solid. This side or the right side?
Bottom.
That means she could make, like 1, 1 is there. She has enough beads to make 1 necklace and 1 bracelet, obviously. She has enough beads to make 2 necklaces and maybe 3 bracelets. Everything in here works. That's how many beads and bracelets she can make. Now, your homework tonight has a problem just like this. It's on the back page. It's the whole page because I made you a big old graph that you can use. I want you to do it first. Because if you don't have that story problem done, I'm not even going to look at the rest of your homework. So do it. You need to know how to do a story problem with 1 inequality because on Monday the lesson is to do 2 of them at the same time and see where they overlap. Yeah.
Okay, well, so technically, if we get a 0 because we don't do the story problem, if you do the story problem, you should get 100%, right?
Nope. Doesn't work both ways in this class.
Okay.
It's unfair.
Alright.
Doesn't it?
See, he's trying to get out of his homework. The point is, if you don't have your story problem done, I'm not going to flip over and look at the rest of your homework.
Okay.
So I think you didn't do it.
Alright.
Even if you did, I'm going to think you didn't. I just want you to do the story problem. I can't tell you, in a day's time with 150 students, there are probably 20, almost every day, that don't do the last problem. No matter what it is. I need to redo all my worksheets and make the story problem first. I really do.
Well, what if they did everything but the first one?
What if? You're asking me to pretend that I have slackers in my class.
You don't.
I do,
You
but I like to pretend like I don't. Don't like slackers.
Okay.
Jake.
I'm a hard worker and slackers drive me crazy. Okay, now I'm going to show you one that you forgot how to do. How do you graph that? Luke?
It's so it's y equals 3. So you go up 3 on the y-axis, and then it's like a.
You go, Luke.
0 slope.
Remember Bucks Hoy?
Yep.
Anybody new in here? I made the kids memorize Bucks. You don't know what this means? Oh my gosh. Okay. If you have an equation that doesn't have any x, it only has a y, like y equals 3, then it is a horizontal line with 0 slope. Isn't that great? Yeah. So, and by the way, y equals 3 means this. It means you have a t-chart and all these are 3s. This could be anything. So, 1, 3, 2, 3, 4, 3. Anyway, so we're going to go up the y-axis to 3, and that's y equals 3. X equals 3 is an undefined slope. What is that?
It's a no phone.
Oh, who gave me their phone for a pencil? That's his phone. It's not mine. Mine's right here. And here now. Huh? I just got it yesterday. Anyway. Okay, if you have x equals something, it's a vertical line and the slope is undefined. It's the greatest thing in the world. Mrs. Byers thought of it. She says Vux Hoy all the time. I even have it up here. Vux Hoy. Okay?
I can't either.
like another language or something.
Sounds like German to me. Anyway, if I change this to y is greater than 3,
Oh,
what do I do to this?
top.
We're going to shade the top
And slash it.
and make them dashed.
How do you do that?
How do you do that, what?
Never mind.
On your paper? You don't make it solid to begin with. Okay, let's do x is less than or equal to 5. How do I graph it? Vux.
X-axis.
We're on the x-axis. This is the x-axis. We go to 5. 1, 2, 3, 4, 5.
Straight up and down.
Vertical line. And it's going to be solid. Where are the numbers that are less than 5?
Left.
Over here. Got it?
That's easy.
Easy? Okay, that is today's lesson.
Alright.
No, it's
Now, 9 of you are going to, you can turn this off. 9 of you are going to get